Hi guys, it's Talha here again today. I hope all of you guys are doing great. So yesterday we discussed some topics in calculus. So yesterday what we discussed was about trigonometric ratios. That was sine, cos, and tangent. So today, actually I've never done this before, but today what we are going to do is going to solve some questions of our exercise 1.6 which we never did at the university because the teacher told us that this is pretty easy and you guys should just know the thing or two about radians and degrees, and I know how to convert how to convert radians to degrees and vice versa, but I still decided to do this exercise anyway. So this exercise so yes, I've prior to this I've explained what are radians, what are degrees, I've explained what are trigonometric functions. So today what we are going to do is going to solve some questions. So in exercise 1.6 radians, degrees, and circular arcs, we have number one, our first question. Our first question is, on the circle of radius 10 meter, so we have r equals 10 meter, how long is an arc that subtends the central angle of A? So first, arc of angle, so we have theta equals 4 pi by 5, and in second, so first part of the question is this, and you know the B part is when you have r is still 10 meters, but your B part is the angle is 110 degrees. So they're telling us to find the length of the arc that subtends this angle first and then this angle. So this is in radians and this is in degrees, but we can also convert degrees into radians, so you guys don't need to worry about this. So here, what is the formula that involves radius and your theta and gives you the length of the arc? Well, that is S equals r theta. So what we do, we put the values. Our r is 10, our theta is 4 pi by 5. Here it gives you 2, so that gives me 8 pi meter. So this is the length of the arc which subtends this angle. And now let's first convert this degrees into radians. So as I explained earlier, pi radians equals 180 degrees. What we want to do is leave 1 here so we can multiply that by 110. So what we do, we divide by 180 here and 180 here. So what we do, we get 1 degree equals pi by 180 radians. Yes, pi by 180 radians. So what we want is, we want 110. So what we do, we multiply 110 degrees equals 110 degrees into pi by 180. So what it actually going to give us is 522 and 530s are 150, 30, 32, 34, and 30, 36. So we have 36, we have 11, we have 1, 8, so 11 by 8. So we have so we have 11 pi by 8 meter. So we have 11 by 8 pi radians. So 110 degree is actually 11 pi by 8 radians. So let's put these values into S equals r theta. We have S equals 10 into 11 by 8 pi. So what we get? We get 2, 4, and 2, 5. So 5 11s are, we get 55 pi by 4 meter. So this is how you calculate the length of the arc that subtends certain angle. I'm sorry, I have this glove which I'm using to erase the stuff I'm writing down. I could only find this glove near me, So that's why I'm using this. All right. So let's do the second one. A central angle in a circle of angle in a circle of radius 8 is subtended by an arc of length 10. Find the angles in radians and degrees. So it's just the opposite. So we have a central angle in a circle of radius 8. So we have r equals 8 meter. You guys can, by the way, read the questions from the book. I'm just writing the data over here. So we have a circle of radius equals 8 meters is subtended by an arc of length. So we have length s equals 10 pi. 10 pi is the length. And find the angles. So we have to find the theta. So our formula is s equals r theta. We do some mathematics, we multiply. So what we want to do, we want to find theta. So theta equals s by r. So we put the value of 10 pi by 8. So that'll give us 5 by 4. So 5 by 4 pi is the angle which subtends the arc of 10 pi. So what we did, we just found the angle that we actually needed to find the angle. So that's what we did. We have okay, so the next one is a word problem. We aren't going to do that. Okay, so let's jump down to question number 7. That is question number 7 of exercise 1.6. That is, if you have sine of x equals 3 by 5. If sine of x equals 3 by 5 and x belongs to pi by 2, and pi. Remember, when we use square brackets, that means that these two values are included into the domain. So we have pi by 2. Okay, so what they want is they want us to find the cos of x and tan of x of this equation. So let's look over here. We have sine of x equals 3 by 5. So that means this x is some angle. We need to find whose sine is 3 by 5 equals 3 by 5. So what we can do, we can shift the sign. So x, so what you want to do, first you want to find the x. So x equals, when sine is shifted over there, it becomes sine inverse of 3 by 5. So if somebody asks you what is a sine inverse, or you can also call it arc sine of x. So what they actually want, if they have a value over here, for example 2, so what they actually mean that the sine of some angle is 2, and they actually want you to find that angle. What is that angle whose sine they calculated, and that is 2. So here this is the same thing. So what you're going to do, you're going to find first the theta or the x, and you shift the sign over there, so you have sine inverse 3 by 5. So if you calculate sine inverse 3 by 5, that is actually, you are going to get x equals 36.6 degrees. So if you now you have the angle that is 36.6 degrees. Now what they want you to do is they want you to find the cos of x and tan of x. So what you're going to do, so cos of x, so what you're going to do is put the value of x over here. So cos of 36.6 degrees, you're going to calculate that is going to be equal to 0.66 something, and that is congruent to minus 4 by 5. And then you have tan of 36.6, and this is, I don't know, I'll have to calculate it, but this is going to be some x, this is going to be some value, and that is going to be your tan of x. So all of these questions are like this. So I hope you guys can do the rest. Basically we didn't do this exercise at the university, so I thought of doing some questions from this exercise, so I could help you guys, and I hope it also helps. Next we have graphing trigonometric functions. So graph the functions in exercise 13 to 22. What is the period of each function? All right, so first what they want us to do is to graph the function sine of x. All right, so as I explained yesterday in a video, that any coefficient over here is going to be the amplitude, of the function. So here it is 1, so 1 equals the amplitude, and okay, so sorry, it's sine of 2x, and the period, any coefficient over here with the x is going to be it's also going to be your period. You're going to find the period by the equation 2 pi by p equals 2. So p shifts over there, so 2p equals 2 pi. You divide by 2, that gives you p equals pi. So that means the period, so generally the period of a sine function is 2 pi, but here they gave us 2, so we calculated that the period of sine is going to be just pi. So let's graph the function. Alright, so our amplitude is 1. It's pretty easy actually. It's just the general sine function, except that you have the period that is pi. So here we have pi by 2, and here we have pi. Here we have minus pi by 2. Here we have minus pi, and here we have 1, 2. We have minus 1 and minus 2. Alright, so we have the amplitude that is 1. So what we are going to do is just going to draw an asymptote. We're just going to draw an asymptote which intersects at positive 1 and which intersects at negative 1. I actually wrote them pretty big, so here. So these were the asymptotes. Alright, now so its amplitude was 1, so that means from the origin, from this point, is going to be 1 up and 1 down. That's what how you're going to incorporate amplitude in this graph. Now you have sine of 2x, and the period of this function is pi, so that means it's going to repeat on this up till this pi. It's going to go up till this pi, and then it's going to go forward and repeat itself again. So you have so it's going to start here, it's going to come here, right here. So that is what this function is going to be, because it's period, period. No, alright, I think I drew it a little yes, I drew it wrong here. It's like this. Alright, so this is going to be the function of sine, because its period was pi. So what it's going to do, it's going to go like this up till here, and then it's going to repeat again and again. Same on this negative side. Its period, so period is from here to here, that is pi, and its amplitude, which is here to here, that is 1, and 1 from here as well. So there you have this function. Alright, now let's do the second question. Let's do the second one, which we have sine of x by 2. So it's here, its coefficient is 1. 1, so that will be the amplitude is 1. And here you can also write is a sine of 1 by 2 into x. So here the x's coefficient is 1 by 2. So what you're going to do is put 1 by 2 in the equation. Pi by p equals 1 by 2. Going to multiply b by p. So p by 2 equals 2 pi. You're going to multiply, so that's going to give you 4 pi. So 4 pi is going to be its period. So its period is so its amplitude is 1 and its period is 4 pi. So let's just graph it. Try to draw a neat graph. All right. So here you have here you have pi. Here you have 2 pi. 2 pi. Here you have 3. Here you have 4. Same here. And its period is 1, so it's going to oscillate, or it's going to repeat up until this and this 1. And this is a pi, 2 pi, 3 pi, 4 pi. Same here, minus 2 pi, minus 3 pi, and minus 4 pi. So its amplitude was 1, so it's going to oscillate. It's going to repeat. It's going to be bit. It's just, you know, sine function is always between 1 and minus 1. So that's why, unless and until you have its scaling, or you shift it or you scale it, but it's still going to be 1. So here you have its period is 4 pi. So what is going to do, it's going to at pi it's 0. So it's alright. So here, yep. So at 0 sine's function is 0. So we have this point. At pi by 2 it's 1. It's 1. So we have, okay, it got me a little confused here. So we have the period of pi, its period is 4 pi, but here if we okay, so like this, okay, so at 2 pi it's 0. At okay, so like this, I think it's graph, it's going to be like this. But here at pi you have at pi you have sine equals 0, but it's giving you 1. Alright, I'm a little confused in this, so we'll but its period, we just got to know that its period was 4 pi and you have its amplitude was 1. So I'm going to confirm it, and I'm going to add it in tomorrow's video. So that was the graphing questions, and we had trigonometric identities, where you have given, for example, cos of x minus pi by 2. So what is the formula? Cos a plus a minus b equals cos a dot cos minus b plus sine a dot sine minus b. So with this formula you can solve this question, and you have sine a minus b equals sine of a dot cos of minus b plus cos of a dot sine of minus b. So here you have these two formulas you can use, and you can use them to solve this question. For example, we have sine x plus pi by 2. So using these formulas you can easily solve these questions. I don't have that much time, so I'm going to end the video right here. I hope this video helped you guys somewhat, and I'll see you guys tomorrow.